Hello mate and welcome to Let's Code Season 6. This is a long awaited. I know I've been away for quite a while, so I'm not going to mess around. We're just going to jump straight in and get on with the important stuff here. So we're going to start a new game, and I'm going to talk about the type of game that we're going to create in a moment. But the first thing that I want to talk about is we're going to do things as logically as possible, and we're going to try and follow code conventions in this tutorial series. In the previous Let's Code series and the videos that I've made on the channel, what I tend to do is keep things as simple as possible, which doesn't always necessarily mean that I'm following the best coding conventions, because sometimes it's easier to explain a subject without all of the niff-naff and trivia involved in all of the extra stuff. So what we are going to do in this series is we're going to make sure that we document our code properly, and we're also going to work from a game design document. What is a game design document, I hear you ask? I'm very glad you asked that question. A game design document is a Word document. It doesn't have to be a Word document, it can be any document you want, but ultimately it needs to be some kind of plan for your game. Now, I've already started doing one here, and this is kind of the layout that I'm going to work with. If you want to work alongside with me, you don't necessarily need to worry about this step, but if you plan on making your own game, it's vitally important that you create a game design document. And this is a really rudimentary, not particularly good one. This is just literally some notes that I threw together prior to making this video so that I had something to demonstrate and talk about. But ultimately, a game design document will be the first thing that you do when you start thinking about what you want to create with your game. It should be a literally from start to finish, cradle to grave, every single thing that you plan on implementing in your game, you realistically should have planned beforehand. Even if you're a really experienced coder, or even if you don't know what it is you're going to end up with, if you just kind of want to code and see where it goes, you should still work from this. Everything that you think of, every idea you have, you should put in your game design document, and then more importantly, think about how you're going to implement it, because at the end of the day, if you don't know how to do something, you can't put it in your game. You can crawl the internet and try and find tutorials and things like that, but if it's not written in your code, when it comes to bug fixing and things like that, you're never going to be able to do it. So that's essentially the document that I'm going to be working from, certainly for the first few episodes of this video series anyway, and then it will probably evolve as I go along and I add new mechanics or things that I didn't necessarily think about in the planning stages. If you haven't done so already, go ahead and create yourself a new Ren'Py project. I am going to be using Atom for this series. It has been sunset, meaning that the support for this product is not ongoing. I don't plan on making this video series last for months and months, so hopefully we'll still work fine when we get to the end. But if it doesn't, we can always switch over to Visual Studio Code. The coloring on the text is completely irrelevant. It's nice to have if you've got a Ren'Py code plugin for your Visual Studio Code or your Atom code, but it doesn't matter. Python doesn't look at the formatting in terms of the coloring of the code. That's just for your benefit. So if you're coding in Visual Studio Code and you're not getting the colors coming up, doesn't matter. There's plugins for Ren'Py code if you want to find them, but that's not important, okay? And what I've done is I've created a new Ren'Py project, and I have moved all of the code currently in the game into a scripts folder. You can do that or you don't have to, it's up to you. Now, what I would usually do at this point is I would actually go through the screens RPY file and split all of the screens into separate folders. But in the interest of getting this series underway, I'm going to just do that as and when I need to rewrite the code for a screen rather than doing it all at the beginning, just because it takes time. If you want to do that, you can preview one of my other Let's Code series. I believe in Let's Code 5 and Let's Code 4, I do that at the very start of the series. All you have to do is just copy what I do in those tutorial series. But it's not vitally important, it just helps us keep things organized, okay? So that's why I'm not going to bother at the very beginning. Now, another disclaimer. This first episode is all full of disclaimers, just to make you aware of what's going to happen. We are going to be using object-oriented programming heavily in this series. and we will be using abstraction or abstract classes and abstract methods. So I will explain what all that means as we go along. But if you do want to do any prior reading before starting this series to give you a bit of a heads up as to what to expect, then obviously by all means do so. I would always encourage people to do extra reading. Right, any other disclaimers that spring to mind? Yes, we will not be using 3D rendering software. I'm going to be drawing my own sprites. You will have to draw your own sprites or create your own art assets for this game. So be prepared to spend some time working on those things as well. Obviously, there probably are asset packs and stuff that you can download. But bear in mind that if you use one of these, even if they claim to be completely free, there's always caveats to these sorts of things. Let me put it this way. Nobody sits and draws for hours and hours and hours and puts all their stuff online for free to people who use unless they're getting something out of it. That just doesn't happen. So if you are going to use one of these asset packs that you can get online, just make sure you're aware of what legal obligations you might have when you use them. Let's jump straight into this then. As you can see in the scripts.rpy file, I have removed all the code apart from label start and return. That's because we don't need any of that Eileen nonsense that's in there. That's all very well and good to have to demonstrate how the game works, but we're not going to use it. So we're just going to clear all of that out. And this is where we're going to put our initial stuff to give us a bit of this is how we're going to start the game basically, but other than that we're not really going to use it. What we're going to do is we're going to create classes, and as you can see I've already written 2 lines of code here. I've written init1 Python. This means that as in position 1 in our queue on our initialize script, we're going to call some Python script, and we're going to call this line here. And what we're doing is we're importing ABC and abstract method. These are the 2 things that we need in Python to use abstract classes and abstract methods. Now to explain what abstract classes are. Let's say you wanted to create a life sim that had real life traffic in it. Every single vehicle in that game will have certain things in common, but they will also have certain things differently. You might have a bus, and you might have a car, and you might have a bicycle. Now, those are all vehicles, but as we know, all bicycles are vehicles, but not all vehicles are bicycles. However, they all have certain things in common. They all generally move forward at a certain speed. They all have a certain number of wheels. They can accelerate at a certain pace, so on and so forth. Okay, so what we want to do is we want to be able to create new classes based on a template, or also known as the vehicle will be our template, and then we can create a class for bus, we can create a class for car, we can create a class for bicycle. But we don't want to have to loop through every single bicycle and then every single car and then every single bus, because what we would do is if we were going to make them all move, for example, we would have to replicate the code for each individual type of vehicle. What we can do using abstraction is we can say a bicycle is a type of vehicle, a car is a type of vehicle, and a bus is a type of vehicle. Although they all have their own individual classes, they all inherit from the parent class, which is vehicle. And then when we loop through all of our vehicles, we only have to write the code for that loop once. Hopefully you get what I'm talking about there. It just means that we don't have to keep writing the same code over and over and over and over and over again for their various different types of things that we might have in the game. For example, we're going to have different types of objects in our game, such as food, drink, weapons, armor. They're all going to have certain things in common, like their position on the screen. They all need to have a name. So we can have an abstract class called object, or well, it won't be able to use object because that's a reserved word in Python, but something like a game object there that will have name and position in room, but they all have their own individual use classes, use methods. So when we say this object, use it, it will do what that thing is supposed to do rather than just what the generic class will do. It's going to make a bit more sense when we get into it. Okay, it's going to be a turn-based dungeon crawler, and it's going to use grids for locations. So we're not going to be using pixel locations. I mean, we will a little bit for the drawing of things on the screen, but we're going to use a grid that objects can occupy. No 2 objects can occupy the same space in the grid, and there'll be combat and there'll be pickups and things like that as well. It's going to also use some survival mechanics, which will mean that the player loses food and drink as they progress, depending on the temperature of the room that they're in or the activities that they're undertaking. So fighting will use energy as well as using HP if you get hit and things like that. So there's a whole bunch of stuff that we need to add to this, okay? So it makes sense to make sure that the first thing we do is create our game class. So we're just going to create a class called game. Nice and easy, that, isn't it? Yeah, I know what you're thinking. Wow, that was very complicated. Now, we need an init method in our game. So we have to say def __init__, and then we have to declare the self. And any properties that we're going to create within our game that are not necessarily methods, we need to use in our init method here. So what I'm going to say is we need a player, obviously, we need a map, and let me just refer back to my game design document because I have actually written some notes here. The game class contains the map, player, the player's location, which may or may not be relevant, an objectives list, and an achievements list. Now, objectives and achievements I'm actually going to implement a bit later, but let's just start with this bit, okay? So we've defining a method. Now, any method that we call, we can use these, we have to use curly brackets, as in, it's not curly brackets, parentheses, and whatever we put inside our parentheses are arguments that must be declared when we call it. In other words, if we create an instance of the game class in the brackets, so for example, if I were to type game equals game, inside here, I have to declare what the player in the map is. Self is self-explanatory. That's just a reference to the object itself. So we don't need to actually declare that one, but we do need to give our parameters, which would be a player and map. So we actually need to define those things. Now, we could do this another way, which is kind of where I'm going with this, in that we can actually just get rid of that. Now, there's only going to be one player, and there's only going to be one map. So we don't need to really give these as arguments because they're going to be kind of explicitly stated when we create the object. So what I'm actually going to do is I'm going to create a player class and a map class. So we can get rid of all of this nonsense altogether. And we'll just put pass in there so that our code won't completely fall over and die. And now what I'm going to do is I'm going to create a new class and I'm going to call it player. And then enter there. And now we've got, I'm going to put pass in there again, and then we're going to say class map. So now what I can do is I can actually go with player equals an instance of the player class, and map equals, now as you can see, that's gone blue. What that means is that that's a reserved word. So what we're actually going to have to do is call this game map like that, which is not ideal, but it is what it is. And we could in fact just call it a map with a capital M, because that would not be a reserved word. So you can see there, the problem we have is that properties or fields, we generally want to have lowercase first letters, so we'll just stick with game map for now, and then like that. And what we've done now is we've basically told Python that the class game has two properties. It has a player and a game map, and they are instances of the player class and the map class, which we actually need to create or add some code to when we get there. So in order to get this work, what we need to do is we actually need to put the game class after our map and player classes so that it actually knows what they are, because if we try to call these before they're defined, it will throw an exception. So what you can see here is I've actually moved the game class down below the player and the map class like so. And we are going to have to do a little bit of jiggling around of the code as we go through to kind of encompass or deal with this problem as it occurs. Now, another thing that we could do is we could have a separate file for each class, which may be the way I end up going, And what we'll do is we will change the init number. We'll subtract the init number each time. So player would be 1, map would be 2, game would be 3, and so on, so that those things actually occur in the right order. And then that would mean that we can have these broken down into different files and just makes it a little bit easier so that we can see. So we're going to give our player class a name property, and what we need to do is just say self.name, and we're going to give it an underscore at the beginning, which is kind of like shorthand way of saying that this is meant to be a constant. Python doesn't have constants per se, so we're just going to use underscores to say basically the player should not be changing this manually. It should be either done by a setter method or not done at all. Okay, so we're going to say same and self.setName like so. So we're actually going to call a method in order to get the player's name, and the method we're going to just define that straight away. So we're going to say define name self, and then we're going to say return. And I'm just thinking, actually no, what I'm going to do is I'm going to give them a default name, and if the player wants to type in a name they can, but if the player doesn't input anything, then we're just going to give it a default name. That would make it a little bit safer for displaying things. So we're actually just going to define a temporary variable, which we'll just call PC name. It's Ren'Py.input. What is your, my goodness, I'm having finger trouble today. What is your name? And we'll put a question mark in there just to make sure that it's nice and clear. And I'm going to put a space at the end there as well. And then we're just going to say a max character length of, I'm going to say 12. And the reason for that is that later on when we come to creating the visual elements for our game, we're going to want to put the player's name on the screen somewhere. And if you have a player who's a bit of an idiot and gives you a 30-character name, that's going to potentially push other things off the screen or cause overlapping of text. We don't want that. I think 12 is a perfectly reasonable length for most names. Any more than that, and I think we're just getting into the silliness. So what we're also going to do is PC name equals PC name.strip like that. And that just removes any spaces, so the player's name is going to be one solid, so they can't enter like a bunch of characters with spaces in between them. So we're actually going to start labeling our code now. Okay, so we're going to create a comment by hitting the hash key, and then we're just going to type this method sets the player name. And then this line, ask the player to input their name. And then this line is going to be remove any white space from the name, like so. And then we're going to say, right, we're going to check if the player has input anything. If not, return default name like that. So we're going to say if not PC name equals, and then we just create our default name. So whatever your default name may want to be, you can put in this. I'm just going to give it default name of, I don't know, I'm going to say Matt just because, but that's my name. But you don't have to use that name, obviously. And then we're going to return PC name, like so. So this is a simple method. We've added comments, as you can see, to make life a bit easier for us later. And it also means that for you guys watching this who've never coded before, we'll get to see how coding conventions are kind of meant to be. So the player, we've set a name. I'm going to refer back to my game design document to see what other things I need to add to our player class. So we also have a hit points, and we'll just set that to 100 for now. We also have a health and, food and drink property. So we're just going to add food equals, and we'll say that to 100, and we're just going to use percentages for now. We might change these to other numbers later, like so. And then let's see what other properties the player needs to have. Cash, like so, and then we'll just say 0 for now because we don't start the game with any money at all. And we can also add a list of items for the inventory. So we're just going to say self.inventory equals, and then we're just going to create an empty list for that for now. And we also need some stats, don't we? So self.attack equals, and we're going to set the initial attack value to be 1, and also the same for defense equals 1. And we also want a list of debuffs and buffs. So I'm going to say status effects, and that's going to be an empty list as well. And these are, these are the default values. We can change them later or not, depending on what's necessary. And we're going to have to create a method for adding things to the inventory and taking things away, or adding hit points and taking hit points away. Because again, we want to get out of the habit, which we've used in previous video series, of just manipulating these values directly. It is bad coding practice to do it that way, so we kind of want to get out of the habit of it now. Okay, so we don't need to add comments for all of this stuff. We know what these are. We can just put a hash there and put values like that. And the reason we're doing it this way is so that when I create an instance of the player class, these values are already set and I don't need to input anything, which means that I don't need to come back down here and start putting parameters into these brackets. What we want to do is try and remove as much coupling as possible. What is coupling, I hear you cry? I'm very glad you asked. Coupling is reference to how closely tied together classes and instances are from each other. What we really want is the interface, i.e. what the game class sees when it creates a new player class. We don't need the game class to know how does the player class get this value, how does it do this calculation. All we want it to be able to do is the game class to say, right, player add cash, or player add HP, or player take damage, whatever. It doesn't need to know any of the goings on behind the scenes. So we try and keep as much of that away from the other classes as possible, which is another reason why we don't want to be manipulating these values. And as you can see, I forgot to put an underscore there. We don't want the player to be, or the coder to be manipulating these values directly. We want getter and setter methods so that we can control how it does it very specifically. So let's just say, for example, let's just create one now. So I'm going to say define take damage. Okay. And now in this method, we need a number for how much damage the player going to take. So we're actually just going to put an integer value in here, and we're just going to call it number. And we'll call it num just for shorthand, okay? All we're going to do in this method is we're going to say self.underscore hit points minus equals number. And that's all we're going to do. That's all that method needs to do. But it means that if we were to change how it does that further down the line, we could change this method, but the game class doesn't need to be rewritten. It doesn't need to be changed at all, because we just need to change the value or the calculations that are carried within this method, and it doesn't necessarily have to impact any of the rest of our code. So again, we're keeping coupling as low as humanly possible. Now, obviously there are issues with just doing this, because we have got a defense property and we do have a finite number of hit points. So when we implement this properly, we're going to have to take into account the amount of armor that the character has, any items of protection that they might have in their inventory, and also if the player's HP drops below 0 or to 0, then we need to have a method to kill the character and end the game. So those are things that we're going to implement later on. So one other thing that we need to do before I forget is we actually need to put these inside the init method. So let's just do that now. And then that will solve any errors that you might be getting with respect to the self not defined or whatever. So this code will actually run and it will ask for player's name. Doesn't really do anything else at the moment, but we're going to talk about that later on. So I appreciate this episode has been quite a lot to take in, so I will leave it there. Thanks ever so much for watching. By all means, watch it as many times as you need to kind of wrap your head around the things that we've talked about. But I will see you in the next one. But until then, you take damn good care of yourselves, alright? Bye-bye!